You are watching AutoCAD Civil 3D tutorial on designing of hill road with me Sudhis Amartya on my channel Amartya Technical. On today's lesson, we are going to learn how to provide a super elevation to an horizontal alignment. So before starting the video, don't forget to subscribe my channel and hit the like button. So on super elevation, we're gonna learn how to calculate and edit the super elevation on Civil 3D. We'll see the view tabular editor and also create a super elevation view. So let's go to our drawing, that is horizontal alignment, which I have opened. So you can see the alignment which we have created in the previous video. So what is super elevation? Super elevation is generally tilting of the roadway to an offset. Here you can see in the figure. So super elevation is generally tilting of the roadway to help offset centrifugal force developed as the vehicle goes around a curve. Along with the friction, they are what keeps a vehicle from going off the road. So this gradual elevation must be done gradually over a distance without noticeable reduction in speed or safety. The practical upper limit for the super elevation which we are gonna provide is 7%. In super elevation, we generally have runoff and runout. So here in the next figure, you can see runout, runoff, and full super, and again runoff and runout. So super elevation transition consists of runoff and tangent runout section. This runoff is the length of a roadway needed to accomplish a change in outside lane across slope from 0 to the full super. So we can also say that it goes from level crown to the reverse crown. And for the runout is the length of roadway needed to accomplish a change in outside lane across a slope from normal rate to 0. That means from normal crown, this is normal crown to the level crown. So what is runoff? Runoff. So for the runoff, for appearance, so the runoff is generally provided for appearance and comfort. The length of super elevation runoff should be based on maximum acceptable difference between the longitudinal grade of the axis of rotation and the edge of the pavement. Proper runoff design can be attained through the exclusive use of the maximum relative gradient. So for non-spiral curves, we should place 2/3 of the two-thirds of the runoff. Here you can see. For a non-spiral curve, we should place 2/3 of the runoff on the tangent. This is tangent part, and 1/3 of the runoff on the curve. So this is the curve. So 1/3 will be provided in this circular curve, and 2/3 should be provided in this tangent. So placing a larger portion of the runoff length on the appropriate tangent is desirable. It decreases lateral velocity in an outward direction, which can lead to undesirable side friction due to corrective steer by the driver. And the runout. This is the runout. Runout is determined by the amount of adverse cross slope to be removed and the rate at which is removed. To effect a smooth edge of the pavement profile, the rate of removal should equal the relative gradient used to define the super elevation runoff length. So basically in this figure, you only need to concentrate this one. First there is a runout. It goes from the normal crown to the level crown, and then there is a runoff which changes from from level crown to the reverse crown, and from here there will be a full super elevation, and again it goes back to runoff, that is from reverse crown to the level crown and to the normal crown. So basic super elevation is the composition of this element. So basically it is very difficult to provide the runoff to the two-thirds of the lane in the hill road where there is a curve provided with very little transition length. So here this is our alignment. So in order to provide a super elevation, just click on this horizontal curve. Here you can see a new tab has appeared on your ribbon. Go to this super elevation, click on this calculate and edit super elevation, and here it is asking us to calculate super elevation now or not, or we can go and open the super elevation curve manager. For now we haven't created any super elevation, so we're gonna click at super elevation calculation, and in the next screen you can see the type of the pavement, that is undivided crown, undivided planar, divided crown with median, divided planar with median. We're gonna select undivided crown, and the pivot method is center baseline. Go to the next, and here the number of lane is symmetry, and the normal lane width is 2.75 meter. I think I have shown in the start of the video. And the normal lane slope we're gonna provide is 2.5%, that is this camber slope. Click on the next button, and here you can see we haven't provided any median, so we don't need to calculate this. And here is asking us to calculate it. Here it is asking us whether to calculate this shoulder or not. So you can either unselect this if you don't want to include super elevation on your shoulder, but in this video we're gonna calculate this, and the width of our shoulder with 0.75 meter, and the normal shoulder slope is minus 2.5%. This we don't need anything. Click on next button, and here you can see on the design criteria file we are using NRC hill road standard, and the super elevation rate is provided on the basis of type 4 mountainous and steep, and the transition lane is a new transition lane table as per this code, and the attainment method is ground roadway by transition method. We're gonna have a on tangent for tangent curve, there is 2/3 of the superelevation, 2/3 of the, here you can see that 2/3 will have a 2/3 of the slope, and on the curve there is, and before reaching the curve there will be 1/3 of the runoff on the curve. And for the curve smoothing we would automatically reserve overlaps. For now we won't select this apply curve smoothing, and we're gonna finish it. So now you see there is some warning. For now we're gonna ignore this warning, and here in the superelevation curve you can see our superelevation has been provided. You can see runoff, which we have talked just before. So runoff is from normal crown to the level crown. So this is our normal crown. So here it is has gone to the level crown, and since there is no length to provide for the runoff, it directly goes to the full super, and here is the full super is n. This is for left shoulder, left outside lane, right outside lane, and right outside shoulder. Here you can see let's see in the curve 6 there is level crown, transition out, this is run out and run off. If you want to direct this, let's close this one, and let's see curve 6. So here is a left outside lane and right outside lane. You can see this is a normal crown, 2.5 in either side, 2.5. So the level crown you can see there is a 0% in the left side, and minus 2.5 is for right outside lane. Then you go to the run out mode. In the run out mode you can see it has raised from normal crown to the level crown, and here it goes again to the normal crown. So this you can visualize by from this figure. This is a graphical representation. So here we're gonna add superelevation standard. Okay, okay. Sorry. So we're going to change our scale to 1:100 so that it will be visible in the screen. So here you can see this is our normal crown. So here it is beginning to run out from normal crown to the level crown and to the reverse crown. So here it will follow full super in this circular curve. So here in this portion 1/3 of the curve is raised to achieve this full reverse slope. So now it is full superposition is provided to this curve, and again it slowly changes. There is other curve. So here you can see there is a super elevation here. This is a normal crown, this is a level crown, this is a full super. So in this way superposition is provided to our horizontal alignment. You can also draw this by clicking on the super elevation, create super elevation view. In the super elevation view name we're gonna let it be as this one, super elevation view. The alignment will be hill road. Super elevation view style will be basic. So we wanna display super elevation for the lane, left, right, and left, right shoulder. Just hit the OK button and click somewhere here. So here it has drawn the superelevation curve. So if you want to see this in profile, all you need to do is go to manage, create data shortcut, just save this and open your profile drawing, which is in the production drawing. So since this is all having a data shortcut, so when we save this file, it has automatically update in this profile drawing, because we have created data reference of this alignment. So here you can see our superelevation has superelevation data has shown in this profile view. So in this way we can create a super elevation in the horizontal alignment. So this super elevation diagram has been drawn in this level band. So you can either show this in your band, or if during the printing it doesn't, or you can't fit all the profile in the drawing, all you need to do is just go to the profile view style, and in the band Just remove this super elevation and horizontal crop data and click on OK, and it will only show changes existing and design label. So in this way we can provide a superelevation to our horizontal alignment. And you need to remember one thing: this superelevation is provided on the basis of our design speed. Here you can see our design speed is 20 km per hour. So our superelevation provided as for this 20 km per hour road. So thank you for today. We'll see in the next class. So in the next class we will create a assembly.